Well, welcome back to the morning show.
It's Wise Guys Wednesday, and Mats Selen, physics professor from the U of I, joins us today once again. So, Mats, what are we learning about today?
Well, it's kind of a continuation of last week because I didn't feel like we quite finished the whole thing. We didn't even get to the word buoyancy, as somebody pointed out. so last time we learned that if you have, for example, two gases where one is less dense and one is more dense, the more dense one goes underneath and the less dense one on top. And it's the same for liquids. And so the question for today was, well, we know that steel is more dense than water. So how do you make a boat out of steel and have it float? Okay, and I just demonstrate that. I have a bowl here that's made of steel. It's a dog dish. And if I put it in my aquarium here, it just sinks to the bottom. Right? And so how do we avoid that from happening or keep that from happening? And so the answer, of course, you know, is if you just kind of put it like that so it doesn't fill up with water, then it floats on top.
Right.
And so to understand this, we have to understand where the forces come that actually make this thing float. So I want you, Cynthia, put your finger on there and push down a little bit. Now, the harder you push, the harder it pushes back up, right? So if it just floats, if you want to get it down underneath, then you got to push pretty hard. So the way this works out is that the upward force on this thing is the weight of the water that this thing has pushed out of the way when you push it into the water. Okay? And so the way you can see that, if I just take this water bottle, which has water in it, so the weight of this thing is just the weight of the water that it pushes out of the way, essentially, and this thing just kind of hovers. It doesn't go down or up, it just floats.
Okay.
Okay? So, what I'm saying is that the explanation is whatever weight of the water that something pushes out of the way, that's the upward force on it from the water.
Okay.
And we've experienced this, right? If you pick something up underwater, it feels lighter than if it's out of the water, right?
Yes.
So here, I have this thing, I'm weighing this piece of aluminum, and it looks like it has a weight of about 9 newtons. If I just put the aluminum underwater, then you see the scale go down to about 6. Okay, so the difference is like 3 or so newtons. So that means that the upward force of the water when this thing is in the water is about 3. And it only depends on how much water this thing pushed out of the way. So let me take this thing, which is exactly the same shape and size as the aluminum one, but it has a little bit less mass. I'm just going to put it like this. So its weight to begin with is about 4. I put this thing into the water, and now you see it's about 1.
Oh,
okay. So the upward force on this was the same. It was about 3.
Much water out of the way.
Yeah, because it put that much water out of the way.
Got it.
So that's how you figure this out. So this thing, if I filled it with water, it would be a little over a cup. So this thing, if I push it all the way down, I would be displacing a little over a cup of water, and a cup of water weighs like 250 grams or something like that. And so if I can put this 200-gram weight in here, it pushes it into the water, but not enough to sink it. Sort of like that. Okay, so the last thing I want to show you, which is kind of cool, are these 2 pop cans. You've seen pop cans before.
I have.
Okay.
We're gonna do it after this.
Yeah, so what's inside a pop can is mostly water, let's be honest.
Yep.
And so this thing has water and a little bit of sweetener in it. And if I put this diet soda in there, it floats because if I look at the overall density of this thing, which includes the outside aluminum and a little bubble of air that's inside and the water and so on, it's a little bit less than the density of the water that surrounds it, so it floats. Here's a regular soda. What's the difference between the regular soda and this one? What's in this one?
Sugar.
Sugar. A lot of sugar. Lots of sugar. So if I put a sugary drink in there that's not a diet drink, it floats, sinks to the bottom. Okay? So you can see the difference just by adding a bunch of sugar to the liquid. You increase the density of that liquid, right?
Yep.
So it's denser than water, and the thing sinks.
Wow.
So that's pretty cool.
Cool stuff.
And it's something you can do at home.
All right.
Save some calories, some sugar.
Yeah.
Go diet.
Well, but sugar gives you energy too, right? So you gotta weigh it. Yeah. But I prefer this one.
All right, you're always looking for ideas, right?
I would love to have more questions because we got some great questions already, and I think that what I'd like to do is to have every time we come in here and do something, I want to answer a question and kind of riff on it because I think it would be really interesting. So please send questions. I think
they can put them on our Facebook page. That means that we need questions from you.
Yes.
So our wise guy can answer them.
Yes,
Matt,
absolutely.
thanks. We'll be right back.